Physics is the study of the universe. It is a field that seeks to unravel the mysteries of existence, from the tiniest subatomic particles to the grandest cosmic structures. The laws of physics are the rules that nature follows, and by studying them, we can gain insights into the very fabric of reality. It seeks to understand the fundamental laws that govern everything from the smallest particles to the largest galaxies. These laws are universal, applying equally to the quarks inside an atom and the stars in a distant galaxy. Through experiments and observations, physicists strive to uncover these laws and understand how they shape the universe. By understanding these laws, we can better understand our place in the cosmos. Physics is everywhere. It is in the motion of the planets, the energy of the sun, and the forces that hold atoms together. Every phenomenon we observe, from the falling of an apple to the orbit of a planet, is governed by the principles of physics. It's in the way a ball bounces, the way light travels, and the way sound waves move through the air. Physics explains why a basketball returns to your hand after hitting the ground, how light bends when passing through water, and why we hear echoes in a canyon, and even the way our bodies move. The muscles and bones in our bodies follow the laws of mechanics, allowing us to walk, run, and jump. The electrical signals in our nerves and the light entering our eyes are all phenomena that can be explained through physics. Understanding physics can give us a deeper appreciation for the world around us. It reveals the hidden mechanisms behind everyday occurrences, showing us the beauty and complexity of the natural world. When we see a pendulum swinging, we can appreciate the forces of gravity and inertia at play. It's like having a secret decoder ring for the universe. With the knowledge of physics, we can decode the mysteries of nature, understanding how and why things happen. This knowledge empowers us to make predictions, solve problems, and innovate in ways that improve our lives. Once you understand the basic principles of physics, you can start to see the world in a whole new light. The colors of a sunset, the arc of a rainbow, and the twinkling of stars all become more meaningful when you understand the physics behind them. Physics not only explains the world but also enriches our experience of it, making the ordinary extraordinary. Matter is anything that has mass and takes up space. It's the stuff that makes up everything in the universe, from the air we breathe to the stars in the sky. Think of your desk, your chair, even your own body. They are all made of matter. Matter exists in different states like solid, liquid, and gas. Each state of matter has unique properties. Understanding these properties helps us understand how matter behaves in different conditions. Energy is the ability to do work. It is a fundamental concept in physics that underpins much of what we observe in the natural world. From the smallest particles to the largest galaxies, energy is the driving force behind all motion and change. It's what makes things move, change, and happen. When you see a car speeding down the highway, a river flowing, or a child running, you are witnessing kinetic energy in action. Kinetic energy is the energy of motion, and it is present in any object that is moving. Without energy, the universe would be a very boring place. Imagine a world where nothing moves, nothing changes, and everything is static. It would be a lifeless, unchanging void. Energy brings dynamism and excitement to our universe, making it vibrant and full of life. Energy can exist in many forms, such as kinetic energy, which is the energy of motion. When an object is in motion, it possesses kinetic energy proportional to its mass and the square of its velocity. This means that the faster an object moves, the more kinetic energy it has. Potential energy, which is stored energy, is another important form of energy. This type of energy is stored in an object due to its position or state. For example, a rock perched on a hill has gravitational potential energy because of its elevated position. If it were to roll down, that potential energy would be converted into kinetic energy. Thermal energy, which is heat energy, is another form of energy we encounter daily. It is the energy that comes from the movement of particles within an object. The faster these particles move, the more thermal energy the object has. This is why heating a pot of water causes the water molecules to move faster and eventually boil. Energy can be transformed from one form to another, but it cannot be created or destroyed. This transformation is a fundamental aspect of energy. For instance, when you eat food, your body converts the chemical energy in the food into kinetic energy for movement and thermal energy to maintain body temperature. This is the law of conservation of energy, a fundamental principle in physics. It states that the total energy in an isolated system remains constant. This means that energy can change forms, but the total amount of energy remains the same. This principle helps us understand and predict the behavior of physical systems, from simple machines to complex ecosystems. Force is a push or a pull that can change the motion of an object. It's what makes objects speed up, slow down, or change direction. Imagine pushing a shopping cart. You are applying force to move it. Forces are all around us, acting on objects in countless ways. Understanding forces is crucial for understanding how things move and interact in the physical world. Section 5. Fundamental quantities, the building blocks of measurement. In physics, we use fundamental quantities to describe the properties of the universe. These quantities are the foundation upon which all other measurements are built. These fundamental quantities include length, measured in meters, mass, measured in kilograms, and time, measured in seconds. These quantities are considered fundamental because they cannot be defined in terms of other quantities. Section 6. Derived quantities. Putting the pieces together. Derived quantities are physical quantities that are defined in terms of fundamental quantities. These quantities are derived from combinations of the fundamental quantities. For example, speed is a derived quantity calculated by dividing distance, which is length, by time. Other examples include acceleration, force, and energy. Derived quantities provide a more complete picture of the physical world by combining and relating different fundamental quantities. Section 7. Scalar and vector quantities. Magnitude matters. Physical quantities can be classified as either scalar or vector quantities. Scalar quantities have only magnitude, while vector quantities have both magnitude and direction. For example, temperature is a scalar quantity. It tells you how hot or cold something is, but not in which direction the heat is flowing. Velocity, on the other hand, is a vector quantity. Understanding the difference between scalar and vector quantities is crucial for accurately describing and predicting physical phenomena. Section 8. Friction, a force that opposes motion. Friction is a fascinating and complex force that we encounter in our daily lives, often without even realizing it. It is the resistance that one surface or object encounters when moving over another. This force is what makes it possible for us to perform many everyday activities, but it also presents challenges that we must overcome. Friction is a force that opposes motion between two surfaces in contact. When two surfaces come into contact, the microscopic irregularities on each surface interact, creating resistance to motion. This resistance is what we call friction. It can vary greatly depending on the materials involved and the nature of their surfaces. It's what makes it harder to push a heavy box across a rough floor compared to a smooth one. On a rough surface, the irregularities are more pronounced, leading to greater resistance and making the task more difficult. Conversely, on a smooth surface, there is less resistance, and the box moves more easily. This principle is why we often use lubricants to reduce friction in machinery, and why smoother surfaces are preferred in many applications. Friction can be both helpful and harmful. On one hand, it is essential for many activities. For example, without friction, we wouldn't be able to walk, drive, or even hold objects in our hands. On the other hand, friction can cause problems, such as wear and tear on mechanical parts, leading to maintenance issues and the need for replacements. It allows us to walk without slipping, but it also causes wear and tear on moving parts in machines. The friction between our shoes and the ground provides the necessary grip for walking. However, in machines, friction can lead to the gradual degradation of components, necessitating regular maintenance and sometimes costly repairs. Understanding friction is essential in fields like engineering, where it plays a crucial role in designing everything from brakes to tires. Engineers must carefully consider the effects of friction to ensure safety and efficiency. For instance, the friction between brake pads and wheels is crucial for stopping vehicles, while the friction between tires and the road affects traction and handling. By studying and manipulating friction, engineers can create more effective and durable products, enhancing our daily lives in countless ways. Section 9. Gravity, the force that holds us down. Gravity is a force of attraction between any two objects with mass. It's what keeps us grounded on Earth and what governs the motion of planets around the Sun. The The more massive an object, the stronger its gravitational pull. Gravity is a fundamental force of nature that shapes the universe as we know it. It's the force that holds galaxies together and influences the trajectory of celestial bodies. Section 10. Light illuminating our world. Light is a form of electromagnetic radiation that is visible to the human eye. It allows us to see the world around us and is essential for life on Earth. Light travels in straight lines at incredibly high speeds. It can be reflected, refracted, and absorbed by different materials. Understanding the properties of light is crucial in fields like optics, photography, and astronomy.